let's step back for a moment to enols. We can do alpha substitution reactions that are reactions of the enol tautomer. The enol CC double bond is electron rich. Okay? It's an electron rich alkene, and it's electron rich because of a secondary resonance structure. A secondary resonance structure is one that's not as important as the main resonance structure because we have a neutral enol here, but I can make a secondary resonance structure by having that oxygen donate its electrons down in. So that forms a CO double bond that pushes electrons onto the alpha carbon. So that's why in the actual resonance hybrid of an enol tautomer, we have partial negative character on the alpha carbon. So it's an electron-rich double bond. It's quite nucleophilic at the alpha carbon, as it is. So if we have that alpha carbon, and if that attacks a strong electrophile, what we can do, here's just our regular ketone. I can make an enol out of that. The enol is not favored at equilibrium, but even if a little bit of it is there, as long as the enol is the thing that's attacking, as the enol reacts, the keto will form more enol to replace it. That's Le Chatelier's principle. As we consume this enol, we'll just make more of it to make up for it. So a good way to draw this mechanism here is to start out with oxygen donating electrons down in. Right? So you got the enol, the O lone pair donates in between the CO bond. That causes the CC double bond to attack an electrophile, and the attachment is at the alpha carbon. So our Pogel book would draw that as a bouncing arrow, like this. Start with the lone pair of oxygen coming down. The pi electrons in the double bond can bounce off of that carbon and attack the electrophile, right, off of the alpha carbon. So however you want to draw it is great with me. So we've added the electrophile to the alpha carbon, and by the way, there's room for it to add at the alpha carbon because we removed the alpha hydrogen originally when we tautomerized to the enol, right? So that alpha hydrogen ended up on the O, and that's where it is after we do the addition. We have this protonated carbonyl. Base can remove that hydrogen then, and if it's the conjugate base or if it's water or solvent or something, we deprotonate that oxygen, and that gives us a neutral ketone as a product with an electrophile that has been substituted in at the alpha carbon.